So let's do comparison between parametric and non-parametric test statistics. For comparison, a parametric test is a statistical test in which specific assumptions are made about the population parameter. And the distribution here, the test statistics is based on distribution. The level of measurements used is interval or ratio, and the central tendency measured is mean. So we have a completely known information about the population. It's applicable for variables, and for correlation tests, you will make use of Pearson correlation. For non-parametric tests is a statistical test used in the case of non-metric independent variable. The basis of the test is arbitrary. For the measurement level or the scale of measurement used here is nominal and ordinal. And for the measure of central tendency, we are going to make use of the median. Information about the population is unavailable, and the measurement for parametric and non-parametric tests will apply for both variables and attributes. For correlation tests, we can use the Spearman row correlation. So the key differences between parametric and non-parametric tests. So statistical tests in which specific assumptions are made about the population parameter is known to be parametric tests. The statistical test used in the case of non-metric independent variable is called non-parametric test. In the parametric test, the test statistics is based on distribution. On the other hand, the test statistics is arbitrary in case of non-metric. So moving on, it is also parametric when it is assumed that the measurement of variables of interest is done in an interval or ratio level, as opposed to that of the non-metric tests wherein the variables are measured, the variable of interest are measured on nominal or ordinal scale. So in general, the measure of central tendency in the parametric test is actually the mean or the average, while in the case of non-metric test, we measure the median as the central tendency measure. So other key differences between parametric and non-parametric, in the parametric test, there is a complete known information about the population. Conversely, in the non-metric test, there is no information about the population. So the applicability of the parametric test is for variables only, whereas for non-metric or non-parametric tests, it applies to both variables and attributes. For measuring the degree of association between two quantitative variables, Pearson correlation coefficient of correlation is used in the parametric test, while Spearman rank correlation is used in the non-metric test. Okay, so may I give you equivalent test? So if you're going to test hypothesis involving independent sample test, okay, independent sample, and you are measuring a parametric test, so you will use, or we will be using t-test. For non-parametric, the equivalent of t-test, independent sample, but it is involving categorical variables or categories and variables or attributes and variables, then you make use of Mann-Whitney. So if you hear Mann-Whitney test is being applied, then this is a non-parametric test. For paired sample t-test, the equivalent of this is Wilkinson signed rank test. And for one-way analysis of variance, or we have the ANOVA, the equivalent non-parametric test for ANOVA is the Kruskal-Wallis test. And for one-way repeated measures of variance or analysis of variance, we have the equivalent test for that is the Friedman's ANOVA. It is still ANOVA, but it is Friedman's ANOVA. Okay, now moving on, plus in the screen is the hypothesis test hierarchy. So you'll notice that we have parametric test, which is for one sample test. We have t-test and z-test. For two samples, your hypothesis with two samples. We have independent sample and paired sample. For independent samples, two-group t-test is being applied or z-test. But for paired samples, you make use of paired t-test. For non-parametric test, we have one sample test. You can use the chi-square, Kolmogorov-Smirnov, and you can also use the run test and binomial test. But for two samples, we have independent samples and paired samples. So for independent samples, you can make use of chi-square, or Mann-Whitney or median test, or we have the Kolmogorov-Smirnov test. Or for paired sample, we have paired samples can be tested using sign test, Wilkinson test, McNemar, and chi-square. Okay, now let's differentiate ANOVA from that of ANCOVA. So what's the difference between ANOVA and ANCOVA? Now, when we speak of ANOVA, ANOVA is analysis of variance, no? And ANOVA is a process of examining the differences or the difference among means of multiple groups of data for homogeneity purposes. But ANCOVA this time is a technique that removes the impact of one or more metric scaled undesirable variables from the dependent variable before undertaking the research. That's ANCOVA. So you have to realize that we are going to look at the undesirable variables, no, before you're going to make use of or you undergo the research. And definitely this is used for pilot studies. When do we use ANOVA? No? So ANOVA is used for both linear and nonlinear models. And for ANCOVA, only linear model is used. No? So this is the case. You can use ANOVA, right, for linear and nonlinear models, but ANCOVA is used only for linear models. And for the variables that you're going to analyze, for ANOVA, only categorical variables are involved. But for ANCOVA, we have categorical and interval variables can be involved. And then the covariate analysis, you can ignore it using ANCOVA, but ANOVA, but for ANCOVA, you consider the covariate analysis. And then the between group variation, the attributes between group variation is to be treated if you're going to use ANOVA. But for the ANCOVA, you are going to divides between group variation into treatment and covariate, because covariate is considered in the measurement of ANCOVA. And then for the within groups, no, attributes within groups, or we have the WG, to divide the differences will be the applicability that is to be considered in ANOVA. But for ANCOVA, you divide within groups of variation into individual groups, and you also consider the covariate. Okay, so this time, when you talk about ANOVA then, no? So, since we differentiated ANCOVA from ANOVA, so ANOVA is a method of analyzing the factors which are hypothesized or affect the dependent variable. It can also be used to study variations amongst different categories within the factors that consist of numerous possible values, no? All right. It is of two types. There are two types, no? So we have the one-way ANOVA and the two-way ANOVA. So take note, ANOVA is analysis of variance, and this is used to see the variation. Okay. So we have discussed variation in our previous lesson. Variation is actually measured by standard deviation or variances, no? So the square of the square of standard deviation is definitely the variance, and we look at the variation of the data, not the comparison of means, but instead variation of the data, and we are involving already more than two variables here, two comparisons, no? Okay, and there are two types of ANOVA. One-way ANOVA, one way when one factor is used to investigate the difference among the different categories having many possible values. So that's one-way ANOVA. But if it is two-way ANOVA, you have already two factors to be investigated. Okay, so you are going to simultaneously investigate two factors to measure the infraction of the two factors influencing the variable being investigated. So take note of that, one-way or two-way ANOVA. Okay, now let's differentiate. Okay, let's see the differences of one-way and two-way. So for one-way, all right, the hypothesis test that you're going to test here is the equality of three or more population, all right, which is simultaneously done. But for two-way, all right, this is a statistical technique where the interaction between two factors, so there will be two factors already that is influencing the variable that you are studying or you're interested to study, no? Okay, and for one way, it's only one way when there is only one independent variable. And if it is, okay, if it involves two independent variable, we have already two-way. So moving on, for independent variable, if it's just one way, there will only be one independent variable for one-way ANOVA. But if you have two independent variables, so it's two factors anyway, therefore you will make use of the two-way ANOVA. Now, definitely for ANOVA test, no, you will have three or more levels of one factor for one way, but effect of multiple level of two factors will be seen if you make use of two-way ANOVA, no? And then for one-way ANOVA, the observation need not to be the same in each group. And so take note of that. If there are two factors, you need to have an equal number of groupings in each group if you are going to have two factors to be tested in two-way ANOVA. And then we have the experimental design. For one-way ANOVA, it needs to satisfy only two principles. Okay, so the two principles we satisfied in the experiment, in the design experiments, no? But for two-way ANOVA, all three principles needs to be satisfied in the experimental design. Okay, this time, let's further define one-way ANOVA then. So, one-way analysis of variance is a hypothesis test in which only categorical variable or single factor is considered. And this is a technique which enables us to make comparison of means of three or more samples with the help of F distribution. And that's why we're going to test the hypothesis using F test, no? And this is used to find out the difference among its different categories having several possible values. So your null hypothesis, therefore, here is the equality in all population means, while alternative hypothesis will be the difference at least one mean. Okay, so you test the hypothesis, and if it is found significant, you need to come up with post hoc analysis. So post hoc analysis for analysis of variance is applied because in the analysis of variance, whether it's one way or two way, you'll say there is significant differences, meaning your null hypothesis is actually um, proven false. And so you have rejected, okay, you rejected null hypothesis, but you need to know what particular extract, if you're talking about extract. So we have four extract. We have the crude extract, we have the 75%, 50%, and then 25%. Now, if there is significant differences, which of these extract came to be significant? And that's why you do post hoc analysis. And post hoc is only used when you are talking about ANOVA, analysis of variance, because you're dealing already with more than two comparisons, no? Okay, so one-way ANOVA is based on the following assumptions. You cannot just immediately use ANOVA or analysis of variance, whether it's one-way or two-way, without satisfying the different assumptions. So first and foremost, the distribution of the population where you're going to draw your sample should be normal. Okay? So it should be normal. So normal distribution of the population from which the sample is to be drawn. Okay? It cannot be skewed. It cannot be skewed to the right or skewed to the left. No. And then measurement of dependent variable is utilizing the ratio or the interval level. So it means therefore that it is a result of measurements. It is not just enumeration data. It is supposed to be utilizing the scale of measurement using interval or ratio. And then two or more, than two or more categorical independent groups in the independent variable. Uh, it is, of course, independent sample. So independence of samples, all right? And homogeneity of variance of the population. So these are the 5 assumptions to be satisfied before you can use the analysis of variance test. Okay, now let's talk about the definition of a two-way ANOVA. A two-way ANOVA is, um, as it names it, okay, signifies the hypothesis test wherein the classification of data is based on two factors. So two-way because there are two factors. And for example, the two bases of classification for the sales made by a certain firm or a certain corporation is the first on the basis of the sale by the different salesman, and the second by the sales in the various regions. So there are two factors that are being considered. So you might not say it's based on the performance of the salesman, but it also depends on the location. So sales is not only based on sales talk of salesman, but sales is also based on the nature of where are you selling the product, okay? Which means that it also depends on location. So there are two factors that you need to look at here. But what is the dependent variable? It is on sales, outcome of the demand. No? So in other words, you make a comparison of several levels and two conditions. So there are two conditions. What are the two conditions? Okay, is sales influenced by the salesman's strategy or salesman's ability, or is sales is influenced by the location, which is regional. So in this case, it involves already two independent factors. And so you make use of two-way ANOVA. Right. So here, there are two independent variables involving multiple observations at a certain level. So there are multiple observations that you need to come out. Okay. Then we have the two-way ANOVA examines now. This is what ANOVA, the two-way ANOVA do. No, it examines the effect of the two factors on the continuous dependent variable. It will also study the interrelationship between independent variables influencing the values, okay, of the dependent variable, if there are. All right. Now, for the two-way ANOVA, there are different assumptions that you need to be satisfied. Okay, you need to satisfy, need to be satisfied so that you can use the two-way ANOVA. So, first and foremost, you have to pick up your samples or draw your samples from a normally distributed population. So the distribution should be normal. And that, okay, measurement of the dependent variable at the continuous level. We have two or more than two categorical independent groups in two groups. And categorical independent groups should have the same size this time. In other words, okay, you have two or more than two groups are to be compared there, but they have to come up with the same number of sample size. And independence of observation is required. Homogeneity of variance of the population is also needed. Okay. Now, another test statistics that we need to understand is the t-test. Take note, what I am giving are all parametric tests. And for parametric tests, there are assumptions to be satisfied before you can make use of this test. Okay, now one of the most commonly used statistical tests is the t-test. And what are the assumptions that you need to satisfy so that you can use the t-test? Okay, the population is infinite and it is also normally distributed. Okay, take note, the population is infinite and it should be normally distributed so that your sample size is taken from the population using a random sampling. All right, population variance is unknown. So your variance or the measure of variability is unknown, and it is estimated only from the sample drawn from the population. And the mean is known. Okay, sample observations are random and independent. So take note. So you're going to pick up your sample size or your sample observations or your sample experiment randomly and they are independent. So the sample size is small. How small is small? Okay, it is lesser than 100. All right. Your H sub O, or we call this as your null hypothesis, may be one-sided or two-sided. So it can be directional or non-directional hypothesis. Now, let's have the definition of ANCOVA. ANCOVA stands for analysis of covariance. So if there is analysis of variance, there is also analysis of covariance, no? And we call that, or we abbreviate it as ANCOVA. Okay, ANCOVA is an extended form of ANOVA, and this eliminates the effect of one or more interval scaled extraneous variable. So take note, we don't want that our data is influenced by extraneous variables, so that you do ANCOVA process. No, from the dependent variable, you're going to perform the ANCOVA before carrying out your results, so that extraneous variables will be um, yeah, eliminated. No, it is the point or the midpoint between ANOVA and regression analysis, wherein one variable in two or more population can be compared while considering the variable um, of other variables, no? The variability of other variables. So when it is when in a set of the independent variable consists of both factors, the categorical independent variable and the covariate, or we call that as the metric independent variable. So there are two factors here, the metric and the metric or the categorical. We call that as the metric is the measurable variable, and the categorical variable, it can be enumeration values. No, so the technique used is known as definitely ANCOVA. The difference in the dependent variable, because of the covariate, is taken, okay, by an adjustment of dependent variables mean value within each treatment condition, and that is ANCOVA. Okay, so let's differentiate now the t-test from that of f-test. So after you've performed your analysis of variance, you will now test the hypothesis using the f-test. Now, the t-test actually is performed when you have already measured the correlation coefficient using Pearson R, and you will test whether the correlation is significant, and you will make use of the t-test. Or you measure the analysis, no, of means, and you make a comparison of two means or a single independent mean as compared to population mean, then you make use of t-test. Now, let's see the comparison. No? So, t-test is actually a univariate hypothesis test. Uni means one, no? That is applied when standard deviation is not known and the sample size is relatively small. So how small is the sample size? Should be less than 100. Now, f-test is a statistical test that determines the equality of variance of the two normal population. And test statistics, T statistics follows now the use of the T student distribution. Okay, this is to identify whether your null hypothesis is rejected or not. Okay, while F statistics follows the Isni-Decor F distribution. So if you hear F distribution, F test is being used, and that is to test the analysis of variance, because you analyze and then you interpret. So you make use of ANOVA and then interpret it using F test, and that is you are going to use the Snedeker F distribution under the null hypothesis. Okay, for the application, we make use of the means of two to compare, okay, while for two population variance is being compared for F test. Okay, now Let's see, therefore, the differences, no? F-test is univariate, and it is applied when standard deviation is not known and the sample size is small. For F-test is a statistical test that determines the quality of variance of two normal population. And for t-test follows t-student distribution for the analysis of your normal distribution, and you'll see whether the null hypothesis is accepted or rejected. You'll make use of t-student distribution. While for F-test, we make use of the Snedeker F distribution for your test of your null hypothesis. And it is applied to compare two population means, right, for t-test, but comparison of two population variance for F-test. Okay, so F-test definitely is defined or is used when you want to describe a type of hypothesis test that is based on Snedeker F distribution under the null hypothesis test. The test is performed when it is not known whether the two populations have the same variance. And that's why you are going to analyze the variances first, whether it's ANOVA, one-way ANOVA, or two-way ANOVA. And still, you are going to test the statistics to determine whether the null hypothesis is accepted or rejected. F-test can also be used to check if the data conforms to the regression model. So it's not only utilizing the analysis of variance, but you're going to test the goodness of fit, and that is the F-test, which is acquired through least square analysis. So we have discussed this in our discussion for the linear regression. And when there is a multiple linear regression analysis, it examines the overall validity of the model, or it determines whether any of the independent variable is having a linear relationship with the dependent variable. And that is for F-test. Okay, but before you can use the F-test, since ANOVA is analysis of variance, there are assumptions. You have already satisfied ANOVA assumptions. You can test whether uh, it is accepted or rejected. Okay, the null hypothesis is to be tested. In this case, you have to follow already the different assumptions. But once that you have already um, satisfied the assumption of ANOVA, then definitely F-test assumptions are also satisfied. So we have the different assumptions. So the population where you are picking your sample should be normally distributed. And of course, this is an inferential statistics. In this case, you have to use a random sampling, or we call this as the probability sampling design, to pick up your samples. So observations are independent, and your null hypothesis can be directional or non-directional, or we call this as one-sided or two-sided.